If it does not interact with the innermost electron, it will not interact with the outermost electron either, and it gives part of its energy to the electron, causing the electron to move. This movement results in scattering, and it is called scatter the photon, meaning the photon gives part of its energy to the electron, which moves with it, at an angle known as the scattered angle. Here, the second interaction is called Compton scattering. Now, Compton scattering is primarily dependent on energy. The higher the energy, the more dominant it becomes over the photoelectric interaction. So, will there be more scattering in the photoelectric effect or not? In scattering, does the photoelectric effect or Compton interaction occur more frequently? Which one results in higher scattered photons? Compton scattering is very significant, especially at high energy. The probability of the photoelectric effect is lower than that of Compton scattering at high energy, right? So, is there high scattering that increases the contrast in the image or decreases it? It reduces the contrast in the image, and this is what happens when you use high kV, giving an average energy of 60 kV. You enter the range where Compton scattering becomes more dominant than the photoelectric effect, which increases the scattered photons. This increase in scattered photons reduces the contrast present in the image. So, the increase in scattered photons has reduced the contrast present in the image. Since there was not complete absorption of the photon, it did not enhance the contrast. Instead, the scattered photon caused distortion in your image. In the case of the local area, the photoelectric effect was the dominant factor, leading to significant photon absorption, which increases the contrast between it and other origins, providing normal contrast. There is another area called the K-edge that the doctor was discussing. What is it? It is that the iodine pigment, specifically the K-shell of iodine, consists of atoms with a nucleus, and the electron present in its K-shell carries an energy of approximately 33 kilo-electron volts. What does it mean that your binding energy is 33 kilo-electron volts? It means that to remove it from its position, you need 33 kilo-electron volts or a little more. The closer you get to this value, the easier it is to remove or extract it from the atom. If you remove this electron from the atom of the dye, you are creating an interaction in the innermost shell. The innermost shell produces the photoelectric effect, which occurs at low energy. Now, what is the average energy in low energy? It's about 40 kilovolts, which is close to 33. So by increasing the energy, you also increase the photoelectric interaction, which in turn increases the absorption of the photon with low energy, thereby enhancing the contrast in the image. Did they contribute in any way? Is this a beneficial or positive thought? Okay, so we have talked about, and we have also discussed in detail, their importance in relation to Compton scattering and their significance. The text is primarily composed of repeated characters and does not essentially convey any meaningful content to translate. In essence, it primarily consists of repeated elements,